Hello everyone. Today I'd like to introduce an AI chatbot. It takes a maintenance request and turns it into a guided conversation. It is an engineered system instead of a black box. It has an LLM at the core wrapped by version-controlled playbooks, deterministic guardrails, and eval hardness and production monitoring. The user's conversation becomes a classified and prioritized work order for a field technician. One conversation, 3 personas, and 1 work order. It is one code base embedded everywhere a request can start. Mobile app, resident portal, or inside of your CRM. Single sign-on per persona, and private personal data stays outside of the URLs. Each conversation ends in one of the 2 good outcomes, either a fully categorized work order or a self-guided resolution that fixed the issue right in the chat. Both are wins. This is an overview of our system architecture. From left to right, we can see the front end hits a CDN and a load balancer. Behind it is a web app that runs on cloud containers. The app calls 3 systems: a hosted model for AI, a ticketing system for work orders, and an object storage system for photos. State lives in a SQL database and a cache. Everything is traced, logged, and infrastructure is defined as code. At the core is a frontier LLM accessed through a cloud API. Inference stays inside of our cloud, and our data is never used for training. The agent returns a JSON formatted response against a schema. The key here is the model only proposes actions, and the server side of code will validate and execute those actions. Domain expertise lives in playbooks, markdown decision trees, 1 per category. They drive both the questions the agent asks and the classifications it produces. We deliberately don't use rec here. Chunking a decision tree breaks it. Playbooks are just files in version control. Every change is reviewed, tested, and instantly reversible. From my AC isn't cooling to a work order, a request moves through 5 steps: initiate, triage, guide, collect, and submit. We pre-warm user details from systems of record. The playbook scripts the troubleshooting, and emergencies escalate instantly. At submit, the server revalidates everything, checks for duplicates, and creates the work order. 2 exits along the way: self-resolution that needs no work order, and an emergency fast lane. What happens if the AI gets it wrong? Every safety-critical decision has a deterministic server-side backstop. Emergencies are redetected in code that force upgrades priority. Classifications are schema-validated. The model can't invent a category. Any failure is saved, flagged for a human, and alerted. Never silently drop. No fallback model. An outage degrades visibly rather than quietly changing behavior. The infrastructure is standard, borrowing in a good-way cloud. Containers behind a load balancer and CDN, fully separate staging and production. Data in managed SQL, cache, and object storage. Secrets in a secret manager. Deploys use short-lived credentials, no long-lived keys in CI. Alerts flow from monitoring through a function to team chat, all defined as code. How do we train the model? We don't. The foundation model stays frozen. All behavior lives in layers we control: prompts, playbooks, taxonomy, deterministic rules, and the Eval suite. Every change is a reviewable diff with instant rollback. No personal data enters training. Adopting a better model is just a config swap plus an eval run. We measure accuracy before anything ships. The eval harness replaces 62 scripted conversations through the real agent code, including 13 zero-tolerance emergency cases. One miss fails the whole run. In production, 3 layers of visibility. We trace every model call. We alert on problems into team chat with deep links. Debug views let you inspect any session. Getting from an alert to an exact conversation behind it takes under a minute. When results miss, we run a tight loop. Detect, diagnose, fix, guard, and ship. Signals come from QA, alerts, dashboards, and evals. Fixes usually land in a prompt or a playbook, almost never the model. Every confirmed bug becomes a new eval, so it can't silently come back. 4 things to remember. The LLM does what it's genuinely good at: conversation and triage, and everything with real-world consequences is validated by deterministic code. The system improves at pull request speed with full audit trails. The same eval harness that protects today's quality is what lets you adopt better models tomorrow. Thanks for watching.